In Tinkerplot simulations, it's sometimes easier to visualize what's going on in graphs and tables if you put filters on the information that is shown. For example, for this graph, a filter can be added so that only information about Abigail is shown. To do this, begin by making a copy of the graph. Then, select Add Filter from the Options menu in the upper right corner of this new graph. And finally, type name equals Abigail into the pop-up window. Now, this process can be repeated for Brittany, Carmen, and Deidre. Notice how the four graphs on the right show much the same information as the bigger graph on the left. But, for the four smaller graphs, the mean values that are shown are particularized for Abigail, Brittany, Carmen, and Deidre. So, some new information is given. To save a history of this new information, filtered graphs do not work as well. So, all of the information that they show also can be seen in just two graphs like the ones shown here. And, these two graphs have the advantage that measurements can be made more easily. For example, select the top graph and then click on Tinkerplot's ruler tool. Then, drag the endpoints of the ruler to 2 points that you want to measure, which, in this case, is the mean value and one of the data points for one of the darts players. Then, ask Tinkerplot to measure all of the other data in the same way, and the results will be displayed at the bottom of the graph. So, if we elect to see absolute distances instead of signed distances, then the results will immediately give a measure of spread in the left-right direction for each darts player. Then, this process can be repeated for the low-high graph. So, for both the left-right and the low-high directions, what these two graphs show is A. How far was it from the bull's eye to the center of the 3 throws, and B. How far was it from the center to each of the individual throws. The first factor can be called something like bias, because it tells how far it is from the bull's eye to the center of the 3 throws. And the second factor can be called something like precision, because it tells how far it is from the center to each of the individual throws. So, the next step is to use Tinkerplot's history tool to make a history of results from multiple games. To begin, click on the location points for the centers for each 3 throws. And then, click on the sum of the distances from these centers. Notice that, when each piece of information is clicked, it is automatically entered into the history table. So, this information can now be combined to create sensible measures of bias and precision for each darts player. To do this, begin by making column for these factors for each of the 4 darts players. Bias for Abigail. Bias for Brittany. Bias for Carmen. And bias for Deidre. Then, precision for Abigail, Brittany, Carmen, and Deidre. Then, formulas can be defined to quantify these factors. For example, statisticians often like to measure quantities like precision or spread using squares of distances instead of straight-line distances. And, in some situations that we'll encounter later, there are excellent reasons for choosing to do this. Or, even for our purposes here, you could use Pythagoras' formula to calculate the lengths of the red sides of the yellow triangles. Or you could use formulas involving trigonometry to produce similar results. But, in any case, our goal for now is to formulate a rule that will end up assigning scores that darts players will believe to be fair and reasonable. And, there's no single, correct way to do this. So, regardless what rule you use, you should test it to make sure that it does not assign scores that darts players will consider to be foolish or unfair. In this example, very simple formulas have been used. The rules simply add the information about horizontal bias and vertical bias to give an overall measure of bias. Then, enter similar formulas for Brittany, Carmen, and Deidre. And similarly, horizontal precision and vertical precision are added to give an overall measure of precision. And finally, scores for bias and precision are added to give an overall measure of darts throwing accuracy. Notice, however, that you might want to weight these two factors in some way. For example, since 3 measures determined precision, but only 1 measure determined bias, you might want to take the average of the 3 precision measures before combining them with the bias measure. Again, there is no correct way to define this function. For example, you could use Pythagoras' formula to calculate the lengths of the red sides of the yellow triangles. Or you could use formulas involving trigonometry to produce similar results. But, in any case, the goal is to formulate a rule that will end up assigning scores that darts players will believe to be fair and reasonable. So, regardless what rule you use, you should test it to make sure that it does not assign scores that darts players will consider to be foolish or unfair. Once you have found an acceptable formula for assigning scores to players, you are ready to pick winners for each round, and to investigate what happens when many rounds are played. To pick winners, use a conditional function that involves a series of if-then statements. An example is shown here. Then, graph the results and run the sampler 100 times. Based on this sample of 100 games, the graph will show the chances of winning for each darts player. First, delete past results. Then, ask Tinkerplots to graph the winners. Then, after a few samples have been collected, pause the graph. Make sure that all winners are being plotted, and then clean up the columns, and ask Tinkerplots to report the percentages in each column of the graph. Then, restart the graph and let it run until 100 samples have been collected. This graph shows the winner for 100 different games of darts. Based on this simulation, which darts player appears to be best? What are the chances that Brittany will win the next game? And, what about Abigail, or Carmen, or Deidre?